a practical coding example of our tutorial on a probabilistic perspective on linear regression. So in particular, what we're going to be looking at is the maximum likelihood estimation version for the ordinary least squares regression. And so what I've already prepared is the following. We have some values that we transform in a way that we generate a number of input values on a range starting from 0 to 500. And subsequently, we define some small error offsets that are sampled from a random distribution, a normal random distribution, and subsequently we define our response variable, and as you can see, this is a linear equation by multiplying each input value by 3 and then adding the corresponding error offset. We put this into a data frame at the intercept, which is needed for the ordinary least squares algorithm here. And then we can basically do ordinary least squares based on the stats models A by I. So let's briefly visualize what we got here. Okay, this actually might be not a convenient example. Let's do this a bit differently. Let's make everything here a little bit smaller, and let's define a smaller range so that we can actually see a little bit more what's going on. So as you can see, we're sampling, given a normal distribution, we're sampling around our values on this line basically. Okay, so and now, as I mentioned, we can do ordinary least squares and can estimate our response line and parameters. Okay, so now what we're going to do is, so this is pretty straightforward. Now we're going to switch to the maximum likelihood approach, and that actually is based on the negative log likelihood. Okay, so we're gonna need some parameters which are to actually be optimized upon. So this is the intercept, this is some value alpha and that's actually what interests us most. And then what we're gonna do is params. So this param is gonna be an array of 3 entries. And that's pretty interesting because we're going to use this. These are the parameters or variables for optimization. And then we can say what is the best y head, and therefore what's the best alpha. So this is this weight vector that we want to return. So here, let's do the following. Okay, so what we need is another library. So from the SciPy stats, we import the SciPy stats, and now what we can do is come up and do, we can build our probability density function with 4 responses here, and then again we get our mean and we get our variance. And so this is where everything gets interesting. Now we've turned this regression problem into the maximization of of the probability density function of the probability, and again this is returned in a way we did a log transform. We put the negative in front so we can again minimize with respect to a more convenient metric. So okay, and then what we're going to do is initial params, let's call this, and now we can start with some initial values. Yeah, let's see, whatever. Okay, so we get initial values for the intercept or alpha weight and standard deviation, and now let's see, and let's do the results. Okay, from SciPy we need the from SciPy there's one thing we need, and that is the minimize function. And so this is what we minimize. So here, first thing that the function takes is our functional definition, and then it needs the initial parameters. So initial parameters. To feed as input. Then we need some method for optimization. Yeah, so there's be a series of methods to go into, and then also we basically force the function to display early results. Given this as optional parameters. So okay, so this is about it. Okay. Yeah, let's rerun everything one more time, making sure that we have everything set up. So this is like this, that, and now we're gonna rerun this part. Okay, and here you can see this is what's going on. We've resulted and terminated the optimization, and yeah, so again, pretty straightforward way to do an optimization. Let's see, did I thing here? Yeah. Okay, log likelihood minus that, and then here we have, yeah, as you can see. So here I just wanted to give this example to see the equivalence. Ordinally squares resulting in a log likelihood of minus 295, and now again, since we've been optimizing the negative log likelihood, we don't have the sign here, but as expected, get the same value. Yeah, so this is it on our small tutorial, coding example for the tutorial to see this equivalence and how easy it can be set up to do optimization.